How's it going, everybody? This is your boy Hollows Grim. Glad to see you all over here. Hope you guys are doing really great. And today we're going to be reacting to what if we nuked the moon. I have my theories. Freaking nuking the moon, probably won't have it anymore. Probably be gone. I mean, judging by the surface area, it'd probably still be there, but it'd be like in the Ruby kind of setting where it's like all chunked apart. Yep. And we'll all have super abilities because of the radiation. Alrighty, be sure to hit that subscribe button. I'm trying to reach 100 subscribers before the end of the year. I would greatly appreciate it if you guys help me out with that. Without further ado, let's get right into this. Bam.
What would happen if we were to detonate a very, very powerful nuclear weapon on the moon? Would the explosion knock its orbit towards Earth, causing tidal waves and misery? Could the moon be destroyed, showering the Earth in a rain of meteoric death?
Oh, this is pretty cool. Kurzgate? Alrighty, Kurzgate, this is your video. Just putting that out there. Be sure to subscribe to him, alright?
During the Cold War, the moon was a major target for space exploration and, military bases.
Sure.
So, the US Air Force commissioned a serious study into the effects of a nuclear detonation on the surface of the moon.
Okay.
But just quoting stuff is boring, so let's conduct a very important scientific experiment with an imaginary 100 megaton thermonuclear warhead about twice as powerful as the most powerful bomb ever detonated.
Damn.
We'll also place a number of curious astronauts around the moon as observers. Let's push the button and slow down time.
Now, the only thing that will be concerning to me is the amount of cosmic radiation that's going to be mixed in with the nuclear radiation. Because remember, the moon doesn't have that much of an atmosphere. So, my prediction based on what I learned in physics, it's probably going to be kind of disastrous. Because if, like I said, there's probably not going to be that much of an atmosphere. But it might be enough for the electrons to bounce back and forth against each other to create an EMP effect. That's why you can't really detonate nukes or anything like that over, how should I say, it's not safe to do that over cities. It's because anything that runs on a computer, a microchip, anything like that, it's going to be rendered useless within a space of probably 750 square miles of where it detonated. Because it's affecting with the ionosphere inside the atmosphere of Earth. That's what causes the EMP effect. So anything with a chip, cars, computers, freaking vapes, phones, anything, even lights, all gone. Anything that runs on a grid is gone.
For the first few milliseconds, nothing much happens outside our weapon. Meanwhile, inside, high explosives send a shockwave to a radioactive metal core, compressing it so much that it reaches criticality and starts a nuclear fission chain reaction.
Probably uranium
the 100
222.
million degree plasma created in this first stage sets off the second stage with atomic nuclei fusing like they do in the core of a star. Very briefly, our weapon contains one of the hottest places in the universe. And only now, barely 10 milliseconds later, does the...
Yeah, because actual nuclear explosion is actually, I believe, 10 to 100 times hotter than the surface of the sun. Yeah, it's that freaking hot. That's why, pray, God rest the dead, freaking all the people who Hiroshima and stuff like that, you can actually still see the shadows of the people who, were killed by the explosion, and it completely vaporized them. They died before even a thought popped into their head. That's how quick it was. Hopefully, if I ever pass away one day, I hope it's that quick.
The rest of the universe find out that anything has happened as suddenly the bomb dissolves and a flaming star of nuclear death is born. So far, so good. But everything that happens now is very different from what we're used to on Earth because of one major difference. There's no atmosphere.
Yep.
As the fireball shines, it releases a flash of X-rays and thermal photons, a wave of silent heat which rushes outwards in all directions. On Earth, this heat would char and burn everything within a 50-kilometer radius at least. But on the moon, without an atmosphere and oxygen-rich air, there's no burning at all. Also, there are no things to burn. The crunchy topsoil of the moon is made from silicate rock and metals chewed to dust by eons of meteorite impacts mixed with tiny traces of water. When heated by the explosion, X-rays from the fireball vaporize a thin cloud of rock from the lunar surface, while the unlucky dust that's inside the fireball melts into glass. Any astronauts watching the show within about 50 kilometers can expect to be fried. And now we begin to see one of the biggest differences between explosions in space and on Earth. On Earth, the atmosphere fights back against the plasma bubble. Its expansion is violently stopped within moments by the pressure of the atmosphere. But this is not good news. As the fireball rams the atmosphere, it produces the most destructive part of a nuclear explosion on Earth, the shock wave. Compressed air around the explosion rushes out faster than the speed of sound, shattering buildings and roaring so loud it ruptures organs.
Yeah, that's another thing. That's why I call it kind of like Call of Duty and stuff like that. It's not very realistic. The only example I can probably bring this to you is, how should I say, a regular hand grenade. Right when you pull the pin, there's a little fuse that goes down the center of the grenade, and you have approximately 4 to 5 seconds to chuck the grenade after the latch is loose, because once that latch comes off, grenade's life. There is no putting the pin back, that nothing like that is going to save that grenade from going off unless it's a dud. And a lot of people think, well, like in Call of Duty, it has a almost like a 5-foot kill radius. No, it does not have a 5-foot kill radius. It has actually a 5-meter kill radius. That is the actual, how should I say, kill range of instant death that will rain upon you when that grenade is actually pulled and thrown. Now, when it detonates, it's not actually the boom you hear. It's actually the explosion pushing apart air, and that creates that sonic boom. Now, if enough air is pushed apart, that sonic boom now has an area of effect, and that's what actually pushes everything away from you that can actually cause damage to organs. Because we can only withstand a certain amount of decibels until our actual compression, because we're mostly made out of water, actually compresses together and actually damages your internal organs. That is exactly what happens. And the same principle is happening here, but on an astronomical scale. That is completely unprecedented. And an actual injury rate of a grenade is approximately, I believe, anywhere from 10 to 11 meters, which is the actual term of shrapnel that's going to actually probably hit you and maybe cut a couple blood vessels and everything like that. So it's, in a grenade, the shock is not enough to kill you, it's the shrapnel that kills you. But in this instance, the shock itself, not even the heat, not anything like that, the shock itself is enough to kill you.
But on the moon there is no shockwave. No atmosphere means nothing to impede the expanding explosion in space. On the moon, the fireball just grows in eerie silence as there's no atmosphere to stop it or to give it a voice. This would be an amazing thing to watch from a safe distance. Unfortunately, there's hardly any safe viewing distance for a nuclear explosion on the moon. Without an atmosphere weakening the deadly ionizing radiation that can scramble DNA, anyone close enough to get a good look will be exposed to fatal amounts of radiation.
Now, the only thing that kind of don't get about this is they don't explain the difference between gamma and alpha particles that are inside nuclear radiation. And so those are the actual particles that are so small compared to, let's say, light, that is actually so much energy being transferred in that such small molecular particles, which they're actually smaller particles than molecules. There's actually quarks, which I'm not referring to My Hero Academia. There's actual things called quarks that are smaller than atoms. Then that's probably about the size of actual alpha and beta particles. And that's what's actually small enough in order to ruin your DNA. Not only that, nuclear radiation is severely toxic. We absorb some of it from here over here on Earth, but it's not enough to kill us. It's enough to actually sustain life. That kind of crap right there, yeah, good luck with that.
But of course, that's not all. While all of this happens, the explosion hammers against the moon, transferring about 1/10 of the explosion energy into seismic waves, powering an intense moonquake. The moon is much smaller than the Earth, and our astronauts will feel an inescapable violent shaking no matter where they're standing. Comparable to an earthquake of 7 on the Richter scale, this shaking could seriously damage or even level infrastructure we might have built anywhere on the moon. Those who hid on the far side of the moon would have no idea it was an explosion. The quaking would feel like an asteroid the size of the Great Pyramid had struck.
Wow.
And it's not over yet. Where our bomb explodes, the ground splatters like water when a rock strikes a pond. As the explosion pushes against the surface, it may excavate as much as 100 million cubic meters of dust and rock, forming a crater 8 kilometers across, while bedrock is pulverized to rubble.
Wow.
Debris is shot into the sky in every direction. Again, without an atmosphere, there's no drag to slow any of it down. Much of the debris scattered never returns to the moon, flying off faster than escape velocity. A flurry of micrometeorites have been cast off to explore the solar system, many of which will rain down on the Earth, though few will be larger than pebbles. Any satellite, astronaut or space station in the way, though, will have a really bad time.
Yep.
Micrometeorites are launched at many speeds and angles, allowing them to spread all over the surface of the moon. Like bullets, they'll punch through our curious astronauts no matter where they stand. Finally, our explosion comes to an end. On Earth, the fireball rises like a hot air balloon, forming a sort of stalk. As it reaches up, cooler air is drawn in around it, rounding the top into a mushroom cloud.
Yep.
But on the moon, well, you know by now, no atmosphere, no mushroom.
Just
The
a
larger
ball.
the plasma gets, the cooler it becomes, and the less energy it has to make interesting or terrifying things happen. Within seconds of pulling the trigger, the bubble reddens and fades from view. It would be visible from the Earth like a star flickering to life, only to fade out right away. A spark, and then nothing. As the cloud of tiny debris reaches far above the surface of the moon, it's illuminated by the sun for a few minutes, giving it an eerie beauty for anyone left to observe the spectacle. What about the moon's orbit? It's basically unchanged. Trying to move the moon with a nuke is like trying to move a truck by blowing on it. Nuclear explosions may be big, but space is bigger. Our
Way
mighty
bigger.
explosion just leaves another crater, one among millions. Still, anyone on the moon will continue to not enjoy themselves. The material that ends up raining back to the moon is radioactive, and without any natural processes to wash it away or bury it, the surface of the moon will remain contaminated. Although fortunately the worst of the radiation will have decayed to a level comparable to natural levels from cosmic rays in about a year.
Oh, wow.
In conclusion, we can say with confidence that while the moon itself does not care about being nuked, and will barely notice, using the moon as a nuclear test ground kind of ruins it for everyone trying to spend some time there or to build something useful. So maybe we should just not do that.
Yeah.
This was our last video of the year 12,020, and oh dear, what an interesting and weird year it's been in all the...
Well, there you have it, guys. That is, what if we nuke the moon? I hope you guys like this video. Please subscribe to CruiseGate? I'm not sure how to say that. CruiseGate in a nutshell. Be sure to subscribe to them. They're the makers of this video. I would like them to get the credit and everything that's due to them. Did a freaking great job explaining everything. Little hints and nuances I'm pretty sure they couldn't fit into it. I hope I covered a little bit if it did not get covered. And yeah, if you guys like this kind of content, please hit that subscribe button. I'm trying to hit 100 subscribers before the end of this year. Would greatly appreciate your help. Without further ado, hope you guys enjoyed watching and have a good one.